A very good afternoon, everyone. Thank you for joining us in our virtual Open House 2021. I am Chu Mei, a Year 2 student from the Division of Physics and Applied Physics, PAP in short, and I'll be your MC for today. Honestly, I'm not very sure what students do in these double majors, but I know how we can find out more. Today's program is as follows. First, Associate Professor Chong Siu-an, who will be sharing with us about our academic program. Next, we have a Year 3 PAP student, So, who will be sharing with us about her student experience. We also have our alumni, Jia Rui, who will be sharing with us what to expect after studying at SPMS. Last but not least, we will be having Dr. Lek Meng Lee, who will be giving us a mock lecture. We would like to welcome you to ask any questions throughout the 1 hour of sharing through our live chat or our Telegram chat at NTU_physics about the program. You can check out our SPMS tours available for limited sign-ups on our open house website too. How interesting, isn't it? Without further ado, we would like to start off the sharing. Let us invite our first speaker for today, Associate Professor Chong Siu-an, to share about the Physics and Applied Physics academic program. Prof. Chong, please.
Okay, thank you, Chu Mei. Actually, what I will be doing is not simply sharing the academic program. I will also talk about the non-curricular aspects of our degree program. So the first thing that students should know coming in this year, August or later, is that the undergraduate curriculum has been changed dramatically. So first of all, now all students are expected to complete an interdisciplinary collaborative core, as well as complete their major requirements. And then there will be a substantial portion that is allocated to broadening and deepening electives. So in the interdisciplinary core, collaborative core, also called the ICC, there will be 17 academic units that are devoted to completing university-level courses. So all NTU students will have to take these courses. And then there will also be about 10 to 15 academic units that are allocated to the college core. So one of them is about communication, so how to write effectively, and the rest will be either professional attachment or professional internship. So we actually, in the 5th Division of Physics and Applied Physics, we offer 4 different flavors of degree programs. The first one is the pure Bachelor's of Science with Honours in Pure Physics. So this would be 62 required core academic units plus 13 electives that is related to the major, or 8 if you do the long professional internship. And then the number of academic units that is allocated for broadening and deepening for this course, for this degree program, will be 30 academic units. And then it's the same for the Applied Physics degree program. So the 2 of them are similar in terms of the AU breakdown, including that for broadening and deepening. So only the courses are different. Now we also have a double major program called Physics and Mathematical Sciences. In this degree program, the core requirement, which includes both mathematics and physics, will be 87, and then 22 of them will be electives that must be completed in order to pass out from this PHMS program. And because it's already interdisciplinary, so the and also already involves some kind of broadening beyond physics or mathematics, so the number of broadening and deepening electives is only 8. The other flavor of degree program they offer is the physics with second major in microelectronics engineering. So here the core requirement is 97 academic units, both in physics as well as in electrical engineering. And then there'll be 13 electives that needs to be completed to complete this degree program. And again, because there is already broadening, there's already interdisciplinarity, students only need to complete 7 broadening and deepening electives. So for the rest of this, this sharing, I will just focus on the major requirements. So NTU physics, so we think of all our students as physics students in year 1. So all physics students coming in year 1 will have to go through a set of 4 year 1 courses, physics courses, to build up their conceptual foundations. They also need to take 3 mathematics courses to complete their mathematical foundation before they move on to take more physics courses in year 2. So there are only 4 physics courses in year 2. There is analytical mechanics, quantum mechanics, electricity and magnetism, as well as thermodynamics. These are the 4 pillars of modern day physics. Then in year 3, the students will then have to decide whether they want to become pure physics students or applied physics students. So we expect pure physics majors to be those who are interested in understanding phenomena in the world around us, whereas applied physics majors would be more technology oriented and interested to work in the technology sector after they graduate. And then of course in year 4 you continue taking some more physics courses, and there are some option to take on concentrations. For pure physics there is only one, nanotechnology. For applied physics there is biophysics, nanotechnology, optical technology, as well as semiconductor technology. And then after that you graduate. So you graduate either with a Bachelor's of Science with honors in pure physics or in applied physics. And then of course the second major program will be on the pure side. This is a double major in mathematical sciences. So in addition to completing the pure physics requirement, you will also be completing the mathematical sciences requirement to graduate with a double major. And then on the applied side, we have the PHME, which is where in addition to completing applied physics major, you also have to complete a second major in microelectronics engineering. So that's our curriculum structure for these 4 degree programs. And then of course sometimes when I talk to prospective students, they will share among themselves that say that pure physics is more theoretical and applied physics is more experimental, and that is not correct. So actually all our degree program emphasizes theory, experiment, as well as computation. Okay, so what do you learn in any of these degree programs? So of course, students, when they ask this kind of question, they expect to hear us talk about all the courses. So these are all the courses, core courses up to year 3. I cannot even put the year 4 courses in there because there are so many of them. But actually, it is not the content knowledge that you acquire during these courses that are important, because in order to pass the courses, you also have to acquire skills. Okay, and then on top of that, we expect, because this is a science degree program, we expect students to become scientists in the process of completing the degree program, and then that will take, therefore, beyond that, they will take a scientific approach to everything. So to working life, to politics, to whatever they like to believe, they should take on these kind of challenges in life as a scientist. Okay, so now let me move on to talk a little bit about why we know that the physics degree program is versatile and employable. So the main reason we believe is because in physics you learn a lot of maths. So here's the mathematics. In fact, there shouldn't be any other degree program apart from mathematics that has more mathematics than physics. Okay, and then of course we have our students do experiments, so they have to collect a lot of data. So they understand how it's how dirty data can be, how you need to clean data, and how to analyze data and present it in a meaningful way. So, and then finally, we expect students to pick up programming. So this is Python, MATLAB, and C++. So these 3 skills form the versatility of a physics graduate. And then in terms of employability, there is no problem also, because we help students along the way. We have a cooperative and education program where students do more internship with a specific company than the other physics students. And then we have offered 10-week professional attachment during the summer, 20-week professional internship either in SEM 1 or SEM 2, and usually done in the year 4. And then of course we also offer a final year project that is tied in and sponsored by the industry. Okay, so this is a breakdown of the kind of careers that our graduates have gone into. This is a little outdated. I haven't had the time to make a new pie chart, but you can see that a lot of them has gone into research. A lot of them has gone into doing their PhD, and some of them after their PhD they continue to work in research. But you can also see that there's a significant number that goes into engineering. Then there's a small number that has gone into engineering after completing their PhD. Not too many has gone into teaching. Then of course, actually one of the biggest sector that is growing for our graduates is data science. So like I said, this is outdated. So if I draw it now, the data science segment, the data science wedge of this pie chart will be much bigger than what you see now. Okay, and of course, you know, if you work in these jobs, you'll be paid handsomely. So this is based on the MOE Ministry of Education's Graduate Employment Survey. So I have this kind of data all the way back to 2008, but of course I cannot show you all of those. You can see that the latest year, the best year for physics graduates is in 2019, but that was pre-COVID. So COVID, you know, put the dampener on a lot of things. So you can see that the mean has decreased, the median has increased. So surprisingly, the 25th percentile has increased, but the 75th percentile has decreased. So, but you know, we expect all these to continue to grow as our physics graduates find themselves becoming more useful and more relevant in the changing economy. So the thing that we're most proud of in terms of value adding is undergraduate research. So students, physics students can do this under Eureka, which is open to all NTU students. They can do it in Odyssey, which is open to SPMS students, and they can also take a making and tinkering course, as well as then of course eventually they will have to choose a final year project. This can also be done overseas, and this can also be tied in with Eureka, and you can see some of the old photos of our alumni working on an undergraduate research project. These two students have both finished their PhD. One of them is working in a semiconductor industry, and the other one is working in Facebook, trying to develop augmented reality capabilities for Facebook. So overseas exchange program, maybe I won't say too much about it because of this fella down here. So, but in the future, you know, 2023, when you actually go for overseas exchange, then there are many, many places you can go to. So we won't talk about that much. So let me just end my presentation now and pass the remote to So.
Thank you, Prof. Chong. Thank you for Prof. Chong once again for sharing on the academic program. I believe that the prospective students now have a better understanding of physics and applied physics program. Having heard all of this as a prospective student at the Physics and Applied Physics program, you may still be doubtful about joining or have some questions for us. As per Newton's first law, an object will not change its motion unless a force acts on it. So feel free to take this opportunity to ask any questions you have through Slido, the website live chat, or our Telegram channel, where our SPMS ambassadors will answer your queries. With that said, let me introduce the next speaker, a current PAP Year 3 student, So, who will be sharing her personal experience as a physics undergrad. So, please.
Hi everyone, I'm So, and thank you for having me. So currently I am in pure physics track in year 3. So over the semesters I have enjoyed attending lectures by different professors, and I find that the year 1 and year 2 modules have become more and more useful as I start to learn about the advanced courses. I found also that professors and the tutors have been very supportive in my learning. In fact, apart from studies, professors are also very open to interacting with the undergrads, such as having casual conversations over lunch or tea break. So that's nice. So now let me dive into my journey in SPMS as a physics undergrad. So I came into physics, wanted to do get to know people in physics. So I joined the SPMS club. So as a physics representative. So you can see that this photo is one of the pre-COVID events that we have organized, and it's called Physics Night. So we hung out at the SPMS lounge to have pizza and play some board games and even play table tennis. So the turnout rate was quite good, but yeah, so now it's COVID, so not really. But even so, we have more activities coming up with the COVID guidelines, following the COVID guidelines and all. Yes. Another main interest of mine is actually research. So one of my first projects in SPMS physics is actually working under Prof. Chung Siu An, who is right beside me. So I actually did a project in Undergraduate Research, Eureka program, studying power laws in protein folding. So I think it really gave me a good exposure, like good taste of research, working, being able to work on computational simulations and so programming. So this is one of the things that Prof. Chung has, talked about. Yeah. And following that, subsequently last year, I took up Odyssey research, and I worked on magnetic systems that is inspired by a real-world system under Prof. Chu Lok Yue, and I managed to present at the Odyssey Research Symposium. So that was a really good experience. And the other aspect of research that I really like is that I get to connect with like-minded individuals from different backgrounds. So you can see that actually I joined a lunch with Prof. Lu Bing Sui and his students. So we were at the Persian restaurant, and we had quite a bit of a conversation, on different cultures. I think all of us came from different backgrounds. So it was like a cultural, so it was like a cultural exchange. So that was really good. So after a while, I realized that, I want to do activities relating to research. So I actually joined the Odyssey program as one of the people in the student committee. So Odyssey program is, catered to all 3 divisions, and we have programs across the semester as well as during the summer break. So for the semester, we have the undergraduate talk series, academic competitions, and concurrent projects. So you can see on the right that is a talk given by Prof. Nelly. So she presented, this was at the start of the semester, so it's quite fresh. So she presented on quantum thermodynamics. Yeah, so it was quite an interesting talk. And on the left, you can see that was during the Odyssey summer research last year. And because of COVID, we had to just stick to the online meetings. But even so, it doesn't stop us from pursuing scientific endeavor. So here we have managed to invite a senior scientist from A-Star, and he actually did a live demonstration and showed us the real-time results of his experiment. Yeah. So another interesting aspect of the Odyssey program is actually the part on interdisciplinary projects. So that means if you come from physics, you have a chance to work with someone from chemistry and collaborate on the project. So for example, I'm from physics, so I actually am working on a small side project with my peers and colleagues from chemistry on quantum computing with applications in quantum chemistry. So that's an interesting one that I'm looking forward to. So, I mean, we don't just do research, we also have fun. So these are a couple of people that I got to know through Odyssey, which I'm very thankful for. So you can see on the left is actually, it was during Christmas where we went to one of our friends' house to bake macarons. And on the right, I chose this photo because it's quite like a candid shot, as it's quite endearing to me. So this was when we went to one of the restaurants in JP because they wanted pizza for dinner, and it's a funny photo. Yeah. So of course, not forgetting, right, a few of my favorite times with my friends from physics. So on the left, this was a whole lot of us taking photo after the quantum mechanics final exam where we actually some of us wore the physics shirt designed by our very own student. Yeah, Rachel is in the photo at the front row in the middle. And yeah, so we took a photo together. So that was a good end to the final exam. And yeah, so during the semester break, I managed to catch up with my friends. And you know, so this really, you know, it really adds, you know, spice to the experience in physics, yeah, for me. So I think so far, it's been an intellectually stimulating and also a fun journey. So I'm really looking forward to, you know, what's in store ahead. And I hope you all have liked my presentation, and hope to see you in physics.
Thank you, So, for your sharing of your university life and your personal experience as a physics undergrad. So had briefly shared about her specialization, and as Prof. Chong has mentioned as well earlier, there are 4 specializations where a physics and applied physics student can choose to specialize in. Remember, you can check out our SPMS tours available for limited sign-ups on our open house website to come over and know more. You can also drop us a message on the Telegram chat at NTU_physics. Next, after having heard from our current student, let us hear from our fellow SPMS alumni who had graduated in 2019 to share about his experience. Let's invite our next speaker, Jia Rui.
Okay. Thank you for having me. My name is Jia Rui. I'll be doing the alumni sharing over for my 4 years undergrad in SPMS. Alright, so this will be the outline of my presentation today. Firstly, I'll start with my self-intro, then my life in SPMS and NTU, and followed by how SPMS actually developed me both academically and practically. And finally, I'll like to hope you have some takeaways from my presentation. Yeah. So self-intro. So my name is Jia Rui, and I have a Bachelor of Science in Applied Physics. And I managed to graduate before COVID. That's why I have a very nice graduation photo without a mask. So throughout my 4 years, from 2015 to 2019, I studied applied physics, and I actually did a concentration in semiconductor physics. So currently, I'm having 2 positions. I'm actually an integration engineer in Global Foundries and also an NTU PhD student in applied physics. So this double position is possible due to this program called the Industrial Postgraduate Program, also known as IPP in short. This is actually something bigger, like actually is a collaboration between GF and NTU, as you can see on the picture on the bottom right. Yeah, this signing of the collaboration is actually witnessed by Mr. Heng Swee Kiat as shown. So some of my job sharing as an integration engineer in Global Foundries, my aim is to integrate the resistive random access memory, which is also known as RM in short, into a circuit level for commercial use. So a simple diagram of the RM is shown here, and it's actually a very simple structure with a metal insulator and metal structure. And due to its simple and thin, it can be integrated into all your Internet of Things devices, which will ensure that all your devices, all your gadgets will last longer, because this simple structure actually make use of lesser processing power, and also you can have more memories being packed in the same area size. So as a PhD student, I'm actually in my year 2, Sem 2 now. I'm working under the supervision of Professor Liu Wenxiang. He's actually an expert in semiconductor field. And as an integration engineer in GF, the work that I do is mostly engineering work. So as a PhD student, I'm actually doing research more on the science behind how these RM work. Okay, and this study will hopefully, and my aim is to apply this study into all the new integration methods, so that the goal of integrating RM into circuit level for commercial use will be fulfilled in the near future. So now I'll share a bit about my life in SPMS and NTU. Right, so one sentence to describe my life, it'll be very, very well balanced and fun student experience. Okay, because in NTU, Uh, yeah, there's actually a wide variety of CCA in NTU that you can go join. Like for me, I actually in Breakers Club. I dance with friends from other disciplines. I do performance annually. And there's also lots of events in both SPMS and NTU, like orientation camps, Halloween event, Valentine's Day. And also there's actually a PAP day for us to come together, have fun, play games, get some freebies from the SPMS committee. Yep. And for academic wise, yeah, it's actually challenging for most of us, yet the curriculum is quite interesting. And if you're interested, like what So has shared, you can actually go join competition or go do research. Wherever you're free, you can form a team and yeah, have fun, work together. And also, SPMS, PB also have overseas exchange opportunities. And I hope that the COVID will go away so that you all can actually experience this firsthand in the next few years. And lastly, definitely there will be a lot of internship and FYP opportunities that is available in SPMS. And you can see from our pictures, actually, yeah, apart from all the very good, nice photos from the events, actually most of your pictures will be random lecture notes, tutorial questions. Yeah, they'll fill up all your gallery that you only see during exams or during when you're doing your assignments. Okay, so some sharing. So my year 3 and year 4 are actually more interesting than my year 1 and year 2 because firstly I got on exchange. I went on a Beijing winter exchange as shown, and I went to Beijing University to study TCM just for fun. Yep, and you can see we went to the Great Wall of China, the Temple of Heaven, and a lot of other places. And yep, I also did some breakdance performance, some other dance performance in my year 3. Following my year 4, I did more performance again. Went to a CAC ball, CAC Social Ball, which is a cultural activity club, one of the umbrellas of CCA in NTU. And I did my internship at Global Foundry, which I continue to as a full-time employee now. And finally, I get to graduate without mask. Yeah, that's a graduation photo with my orientation group, which I'm quite lucky to have. So now, how SPMS have developed me both academically and practically? Definitely, in physics course, throughout these years, you'll study a lot of physics, and definitely you'll be increased in your physics knowledge. But apart from that, to find your interest, actually we are actually exposed, our curriculum exposes us to different physics field like what Prof. Cheong has mentioned. And during these modules, actually they will try to link all these studies, especially in applied physics, to all the engineering and real-life applications, so to gain your interest, to let you know that actually what you are learning actually have a great potential in the commercial world. Apart from that, the SPMS committee also will invite famous researchers from around the world. These researchers can be like Nobel laureates, and yeah, they'll come here and do their sharings of their research and let you get caught up to what is happening around the world. And apart from that, all these are free, and you get to interact with them after their lectures. And now it's mostly done on Zoom, and still all this applies. You still can talk to them, send in your questions, see to show like whether you're interested, ask them whatever that you want to know. And definitely, I've gained some data and information processing skills. Yeah, from all the labs, all the readings. There's lots and lots of articles on the internet. What is relevant, what is not relevant. Yes, you need to process all this fast so that you can complete your assignment, know what you're doing. And analytical skills, definitely we have a lots of labs, sessions, and we'll gain lots of data. What data is good, what data is bad. Why do we have bad data, all this. And then we need to write a report about that and present to show our understanding about that. And other practical development I have, definitely time management. So every semester we'll take around 6-7 modules on average. And yeah, definitely you'll need time management so that you can juggle all your assignments. And some of you I know not planning to stay hall as some of my friends did. So those who are traveling will actually spend a significant amount of time traveling every day. Yeah, so time management is definitely something that I gain, and teamwork, doing projects, doing collaboration between other people, which is actually very, very useful in what I'm doing now in your job, as we need to collaborate. If not, it's hard for one person to achieve something, especially in the world, in working life. Yeah, so teamwork definitely important, and presentation skills, how to pack all the important information within a specific amount of time, and something called the grid. During the study period, during the coursework, definitely the professor will give you a very difficult tutorial question, and you don't know how to do, and you'll be demoralized over and over again. Yeah, and during the study, when you're marking for your finals, during the short period of time, you need to study like 13 weeks of content throughout all your 6 modules. Yeah, the grid, definitely. So how do I prepare for graduation, right? So in order to get a job, definitely you need to do some work on your own so that you can secure an internship or job. Firstly, definitely I found my interest in the field that I like. So during our year 1, year 2, we are exposed to a lot of topics. So after you can explore on what you can study, and I read up and said, hey, actually I'm quite interested in semiconductor field. So then what did I do? I go to career fair, career talks, career sharing. So this is actually organized by NTU Career and Attachment Office, free of charge. You just need to sign up and you can go there and talk to the professionals there. And after you talk to them, you find out, okay, which company is hiring, what are they looking for, when are they hiring, what is pay, know about the job culture, everything. Followed by that, then I'll need to do some work on myself. So after knowing what they are looking for, then I will try to take out more relevant modules from either SPMS, PAP, or maybe from outside faculty. Take out relevant modules, learn the relevant skills maybe on the internet through books. There's lots of resources out there. Then after that, I find a good and relevant internship. Actually, that's what I really did. So I found my passion in semiconductor physics. Then I asked around during career fair, found that Global Foundry is actually doing semiconductor chips and research, everything. So I talked to them, know what they're looking for, and I try to apply to that, which I get quite luckily. Then after that, if you are very scared, like will you pass the interview? Will the HR even look at your resume? So they're actually SPMS career coach. They'll do critique on your resume writing, and also teach you some interview skills, your body language, how you present yourself, how you market yourself. And there's also some lesson on networking, how you can talk to people, do your pitch and let them know what you want and show what you are capable of. So some takeaways that I would like you to have from my presentation today. Definitely, university education is going to be challenging, especially in physics. As you come to university physics, you see lesser and lesser of numbers as you go from year 1 to year 4. But at the same time, it can be fun too, as long as you go join a CCA, make some friends, hang out together. Yeah, it's gonna be it's been a very fun 4 years for me. And also, very important, help is always available in NTU and SPMS as long as you seek it. You can be any help. Like in SPMS PAP, there's actually, I went through a preparation class for ORD NSF. So I served my 2 years. I wear helmet for 2 years. I forgot everything. But then there's actually a preparation class for us to recap everything. Even the females who, after JC, they also can go. Yep, it's for everyone. Then also there's a progressive syllabus, so they won't throw you to do quantum in your year 1, Sem 1, or without having a progressive and let you know what you need to know. Yeah. Also, the tutors are actually friendly and the prof are actually very friendly, so they'll take time to have private consultation with you if you have anything unclear. Yeah, if you are very shy during lectures, during tutorial, don't want to scare you'll make a fool of yourself in front of friends, you can email them, book a time for a private discussion, and they'll clear all your doubts in no time. And I think one of the most important thing in PAP is that they ensure that we are workforce ready. Yeah, so from what I see, actually, for over the years, they have more and more relevant trainings, modules, so that it actually prepare us to know and to know what we can do in the industrial and yeah. And also you can see how from the, like I say, NTU CAO career office, and networking and pitching lessons for you to learn, talk, present yourself, and resume writing. This is actually very important so that you can secure an internship or even a job. And definitely interview skills. Everywhere you go, you need interview. You go through interview, and yeah, and in front of those directors, HR, how you present yourself, how to remain calm and show and market yourself well so that they will sit down and really listen to you and call out for follow-up interviews. So that's all for me, and I hope you gained something from my presentation. So see you in PAP.
Thank you for the sharing, Jiarui. I hope this motivates you even more in wanting to join the Physics and Applied Physics course. From what Jiarui has shared, the university experience has been a really interesting part of his life, and we have learned so much from it. I am glad that Jiarui enjoyed his time here as an applied physics undergrad and is doing well in his post-university endeavors. Even after all the sharing by our speakers today, I think it's indeed best to experience it ourselves, isn't it? Our very own senior lecturer, Dr. Lek Meng Lee, will now present us with a mock lecture. Let us welcome Dr. Lee.
Okay, good afternoon, everyone. So I hope that in this short period of time, I can make you understand one concept, and you're able to understand the concept and be able to work out examples on it. Okay, so the concept that we're going to talk about today is going to be centered on mass. So the way I'm going to teach it is going to be very straightforward. The idea is, if you look at the rough definition, it's just going to be like the point as if all the mass of the system is at that point. So when you put your finger underneath that point, you can support the whole system. Okay? So if you have two masses joined by a stick, you put your finger underneath it, under that specific point, then the whole system will stay there and you can support the whole system. So there is no rotation about that point. So that's the simple idea, okay? You can go further, but it's okay. That much is enough to bring us very far, okay? So now based on this idea where the two masses joined by a stick is not rotating, okay, we can now derive a formula for the center of mass, okay? So look at the picture. So what happens is we will choose the origin to be the blue cross over there, and the distance to M1 will be called X1, okay? The finger will be called the pivot, so there's no rotation about the pivot, okay? And so the distance from the origin to the pivot is called XCM because it's the center of mass distance, okay? And then the distance from origin to M2 will be X2, okay? So now based on your secondary school knowledge, you just need to use principle of moments, that the clockwise moment about the pivot is equals to anti-clockwise moment about pivot because there's no rotation. Alright, so now you can form the clockwise moment, which is M2G multiplied with the distance between M2 and the pivot, which is X2 minus XCM. The anti-clockwise moment is caused by M1. So the moment will be M1G times the distance between M1 and the pivot, so it's XCM minus X1. And rearrange the algebra, make XCM the subject of the formula, and there you go. This is the standard center of mass formula. So it's a very simple concept, and the mathematics comes out naturally. All right. So let's continue on. Yeah. So to push this further, we will now talk about what happens if you have more than two masses. So all you have to do is you just extend the numerator and denominator. So you have in the numerator now you have M3x3 plus ... and the denominator now you have plus m3 plus blah blah blah. So the numerator is the sum of the mass times the distance to the mass, and the denominator is a sum of all the masses. Okay, so the denominator is therefore the total mass of the system. Okay, so we will write it as a big M. Okay, and the numerator will write it bigger. Okay, so now we can push this even further. Okay, so you can see within 15 minutes we can push this concept very far. Okay, so now we'll talk about a continuous mass problem. So what is a continuous mass? Basically, it is made up of many small discrete masses joined together. So for example, a rod. So you can slice up the rod into small discrete masses. So the triangle there is the capital delta, meaning small. Okay, even though it's a capital letter, but it means small. So the distance to that small mass will be xi. Okay? And now what happens is the formula from above will just be modified to xi times delta mi. That's all. Small mass. Okay? So this formula actually is familiar if you now compare with something that you have learned from your A-Maths. Okay? So from your A-Maths or H2 mathematics, okay, you know that the area under the graph is found by integration. And also the area under the graph can be found by making rectangles under the graph. So the area under the graph is actually the sum of all the rectangles. And if you look at the sum of the rectangles and you look at the continuous center of mass formula, they actually look the same. So therefore, the center of mass formula can now be turned into an integration formula. Okay, so this is for continuous mass. Okay, and I can tell you in these 2 slides, we are done with this concept pretty much. Okay, and all the formulas are all pretty much all here. So now we can even go do examples in this short time. Okay, so we'll do 2 examples. So the first example will be a discrete problem with 3 discrete masses, M1, M2, M3. Okay, so we will choose the origin at M1. So we'll put a little blue cross over there. And then what happens is we are going to use the formula measuring from the blue cross. Okay, so M1 times 0, M2 times 2, M3 times 4, and the denominator is the sum of all the masses. So you just plug in all the numbers, work out the answer. So the center of mass is 2.33 meters from M1. That's it. Done. Okay, so now we'll look at the second example, also the last example, which is the center of mass of a rod. Okay, so this is a continuous mass problem because when you slice up the rod, there is mass at every slice. Okay, and we know the answer for this one because by common sense, the center of mass of the rod is in the middle of the rod. You put your finger underneath the middle of the rod, you know you support the rod and doesn't rotate. But let's do it properly. So what happens is the rod is being sliced up. The small mass is now called dm. Okay, and then what happens is that the small mass is density times small length. So density is mass per unit length. Okay, and the small length is dx. The d meaning small. So now we will use the formula, plug in the dm, which is m over l dx. Okay, and since the m over l is a constant, it's not a variable, you take it out of the integral, and you need to sum over from the first mass to the last mass. So therefore you integrate from 0 to L because the first mass is at 0, the last mass is at L. So therefore the integration is simply just x dx. So work out the integration, clean up the algebra, and you get L over 2. So the common sense answer, okay, shown properly to you. Okay, so I hope in this short lecture you actually have a good understanding of center of mass and how the teaching happens in PAP. Thank you.
Thank you, Dr. Leek, for the mock lecture. I still remember my very first lecture experience as a freshman, and I can't wait to start my university journey here at SPMS. As we are nearing the end of our sharing at the Division of Physics and Applied Physics, we will now have a Q&A section via Slido to answer some last remaining questions that you might have. So for the first question we have, is physics or applied physics more similar to what I've learned in H2 physics? Maybe Prof.
So
Chong?
I think I guess I'll take that question. So let me just say that H2 physics is covered from scratch in year 1, and the year 2 students will learn new physics that's not covered in JC. So expect to learn a lot of new things. So the H2 physics can help you in year 1. I guess the more important thing is to start building up foundation for year 1 in physics in university.
Thank you, Prof. Next question we have, is there an option for students to specialize in fields such as astrophysics or quantum mechanics?
So I would need to know what the student mean by specialized, because our concentrations are specializations. So the concentration is the lowest level of specialization at the university level because it consists of 3 to 4 courses. And then a minor will be about 6 courses, and then a major would be in the order of 10 plus courses. So at the undergraduate level, I don't think there are many universities that can even offer astrophysics as a major or a minor. So at most 1 course or 2 courses. We have a course. We don't call it astrophysics. We call it cosmology, and Ming Lee is the one teaching it. And we have lots of quantum mechanics courses. So if you want to think about specialization in quantum mechanics, then every single physics or applied physics graduate will be a quantum mechanics specialist because they take so many of them.
Thank you, Prof. Next, we have a question with regards to more opportunities for future grads. So the question is, will taking pure physics track offer more opportunities for future grads? If so, why and how?
So based on, because I keep track of where our graduates go for many batches already, I don't see any difference between pure physics and applied physics. So those who want to go in the industry, it doesn't seem to matter whether you do pure physics or applied physics. Those who want to go and do PhD, it also doesn't seem to matter whether you do pure physics or applied physics.
Thank you, Prof. All right, the next question we have. I am interested in topics such as cosmology. Are there any relevant modules in SPMS? Maybe Dr. Lee can take this question.
Okay, yeah, it so happens that I'm the one teaching the year 3 module on cosmology. So therefore I'll answer this question. So there are 2 modules that are relevant to cosmology. So one in year 3, cosmology, the title of the module is cosmology and it's taught by me. And in year 4, there's another module which is advanced general relativity, which is taught by my colleague. So yeah, so there are 2 rather high level modules that you can take. Yeah.
Okay, thank you, Prof. Next question we have. Can I apply for PAP if I didn't do H2 physics in my A levels but have pure physics at O levels?
So if you're applying using A-level, using A-level results for university, then the answer is no. So you will need to have done something beyond your A-levels in order to be able to apply to do physics in at least in NTU.
Thank you, Prof. Next questions. Will PHMS students be able to take Industrial Introductory CNY SP modules in mathematics and physics in year 1? Why or why not?
So I'm not sure I understand why there is such a question, because PHMS students take all the year 1 physics courses and all the year 1 maths courses, whereas the CN Young's programs actually is reduced. So they take fewer physics courses and they take fewer maths courses. So why would someone who's already doing all the maths and all the physics want to go and capo the CN Young physics and maths courses?
Okay, thank you, Prof. Next question. Will mathematical topics such as groups, analysis, probability, and statistics be compulsory for all incoming physics undergrads?
I can say that none of this will be required for physics.
Thank you, Prof. Do most physics undergrads choose to pursue a PhD or master's after graduation?
In the Singapore system, very few people actually do masters. Then based on past experience, about 15 to 20% of our cohort actually choose to then go on for a PhD.
Thank you, Prof. Chong. Next, we have a question. I am interested in PHMS double major. In that course, will I be expected to decide on a track such as choosing pure physics or pure math?
The PHMS only applies to pure physics, so there is no such thing as applied physics with a second major in mathematics. The math side has since removed the requirement for pure or applied or statistics, so PHMS students can just take any maths course that they like, so long as they fulfill the core requirement to graduate from mathematics.
Thank you, Prof. Next question. I'm from Polytechnic. Will I be at disadvantage?
I guess the answer to that question is, are you interested in physics? So if you're interested in physics, then there is no real need to even ask a question like this.
Thank you, Prof. Just to add on that question, I'm actually a Polytechnic student as well. So for disadvantage or advantages as a physics student, I feel that there is no disadvantage as a Polytechnic student itself, as long as we have the passion to do what we want, and if we have the interest in doing this course, it will not be a disadvantage for us. Yeah. Moving on to the next question. How's a normal day as a physics student? Maybe we can have So to
I can
take this question.
Normal day. No, my normal day is studies plus research plus a lot of other things. So okay, maybe I'll say for lectures you have 2 hours lecture, and then you have a tutorial, 1 hour tutorial session. Then every week you have a lab session. So lab session lasts for about 4 hours. So it's so that's for lab, and so that's a normal day. So you have that normal curriculum, right? Then whatever that you add on is like accessory, you add on to it. Then so it will determine how busy you are. So for me, I do research. So so I will work on my research things as well. When I'm not too caught up with the workload. But I would say I think nearing the assignment deadlines and lab report deadlines, definitely it gets a bit more hectic. So currently, actually, we are getting through what we call a hell week kind of thing. So we have a lot of deadlines that we are going to have to meet. So and midterms coming up. So yeah.
All right. Thank you. So, all right, we have the next question. Will there be a lot of mathematics component in physics? I am asking this as I am extremely interested in physics, but not so strong in math. Maybe Jerry can take this question.
Mathematic components, definitely there will be, because mathematics is actually, someone said, like the language of the universe. Okay, so everything like chemistry, bio, there's physics involved, and then mathematics is actually in all of this. Yeah, so you're not so strong in maths. I don't think that's a problem, because especially during year ones, we actually have some year one mods that teach you calculus, linear algebra, everything. So there's really a progressive training, so that they'll go through the concepts from what, because I'm a JC student, so some of the concepts are actually similar to the JC or your A math. Yeah, then after they slowly progress, and you see lesser and lesser of numbers, more algebras, and I think it's generally quite manageable. There's thousands of undergrads that's actually a graduate with a strong or weak maths foundation, so it shouldn't be a problem. Yeah.
Thank you, Jerry.
Can I just add on? I mean, as you can see from the mock lecture, right? The physics concept, we can start off with a simple idea. Rather imprecise idea, but we need to use the mathematics to make it much more precise. So you can see that's the role of mathematics, to make physics a very precise thing. So as you go higher and higher in physics, the concepts become more and more precise. So therefore, it's unavoidable that we need the mathematics to to make sure the language is very, very, very precise. I'm sure the students will know that as they progress from year 1 to year 4, the amount of mathematics increases, but that's more or less because to make everything very, very precise. Okay? Yeah. So you just need to learn the math along the way as you are learning the physics. That should do. Yeah.
Thank you, Dr. Lee. Next question we have, will grades from ICC be counted into the overall GPA?
Actually, I am heavily involved, but I also don't know the answer to that question. Yeah. But it's only 17 AU, so, you know, or maybe if you count the PIs, yeah, I think, you know, it's probably not something that you need to worry lose sleep a lot about. Yeah.
Thank you, Prof. Next we have, how often are lab sessions held?
This one, I can easily take that question. Our lab sessions are not part of the course. It is a separate course on its own. So usually what happens is that in the 13-week semester, the first week students do not go to lab, and maybe the last week students don't go to lab, but otherwise they go to lab once a week for the lab course that they sign up for. So they do this for year 1 Sem 1, year 1 Sem 2, year 2 Sem 1, year 2 Sem 2, and then year 3 there's only one lab course that they need to complete for pure physics students, and then they can decide whether to do it in Sem 1 or Sem 2. And then of course after that, when they sign up for FYP and it's experimental, then they have to be in the lab a significant fraction of their time. So how often will be between the student and the supervisor. So the rest of us, we don't really have a say.
All right, the next question we have, when do we choose whether to be in pure or applied physics?
So the earliest that students are asked to make this choice is at the end of year 1, but they can change. So if a student chooses to be in pure, then later realize that they want to switch to applied, they can continue to do this throughout the year 2 and as late as year 3. So obviously, if they have missed something, they need to go back and take again, but in general, we have students deciding between pure and applied physics up from after the end of year 1 to somewhere in the middle of year 3.
Next question we have, can I apply for physics with a business polytechnic diploma?
We accept all polytechnic diploma, so I think we are the only degree program that does so. But because we don't really understand, because there's a huge variety of courses that polytechnic students take, so all polytechnic students applying to do physics in NTU must go through a admissions test. So we test students on simple mathematics, simple logical reasoning, and then we try to ascertain that the student has genuine interest for physics. And if they do well in the admissions test and the subsequent interview, then we make them an offer. So the answer is yes, but of course it is conditional.
I would like to add on. So for that question, I personally actually have a friend who have a business diploma. He did well, but throughout the NS, then he realized that he read on physics and actually it's very interesting, and he's actually interested. So he enrolled in physics, and yeah, so he enjoyed it, and now he actually makes use of the physics skills that he learned, all the graph analysis and everything. And now he's actually working in the financial sector, helping people to invest and everything, look at graph, look at trends every day. And yeah, I think, yeah, it's possible, and it's good for you in the future also, yeah.
All right, maybe the next question Jerry can take. I am in NS now. What can I do to prep for physics, and which textbooks should I read?
Okay, so for what I do, right, like after you ORD and the time I ORD and before I enrolled, I got like a lot of time. So apart from working, I did some read out. I read out on my H2 physics textbook and everything. And definitely the one I shared in my presentation just now, I enrolled in the physics prep course for engineering and physics. And I actually taught by Dr. Lake at that time. And he gave a very, very brief intro on what to expect. And it sort of like bridged the H2 physics, let you revise a bit and bridge and intro a bit of the university physics there. Yeah, so actually you can also go online, watch YouTube videos, everything. Yeah, there's resources everywhere.
Thank you, Zari. Next questions we have. what are some examples of research topics that physics undergrad typically do for Odyssey program? Maybe So can take this question.
Yes. So for Odyssey program, so you see, when you do research, mainly I would say we consider whether we want to do, like, let's say experimental or theoretical. Then depending on that, we work on certain research topics. So if you're doing experimental, you have to be expected, to be spending a lot of time in the lab, building stuff, troubleshooting, conducting the experiments. So, for example, we have ultra cold atom lab in NTU, in SPMS. So then we also, so that is in collaboration with the CQT so CQT, so working on quantum and like ultra cold atom research. And then we also have a couple of groups, I think, doing on quantum related quantum computing as well. So those are like possible research topics. So I myself, I work under Prof Cheong Siuan. So like Prof Cheong, he does on like computer simulations on complex systems and financial markets, that kind. So yeah, depends on what you want to do. Yeah.
Thank you, So. Next question. I have met the IGP and prerequisites of the course, but attained a S grade for general paper. Should I be fine if I apply?
In the past, we have had graduates who actually failed the general paper, but he almost made it to first class. So I think there should be no reason why GP should make a big difference in physics.
Thank you, Prof. I take H3 physics in JC. Will there be any exemptions in modules if I decide to take major in physics or applied physics?
The short answer is no. So the only exemptions that we give to applicants is for the applicant to have won any medal in the International Physics Olympiad or the gold medal in the Asian Physics Olympiad. So only these two conditions, if they are satisfied, then we offer exemptions for the first year courses.
Thank you, Prof. Is it difficult for physics undergrad to secure semester-based summer internships?
So I think maybe the undergraduate student can also answer that, but let me just say that what I have experienced is yes and no. So some of the students complain that they go to the career fair and then the HR people tell them that we don't need physics grads. My advice for students like that is to tell them back and say, but I can do the job. So it should be job based rather than degree based. And then the other challenge that our students fail to recognize is that they produce very bland, bland resumes that contain not enough information. So the companies look at those kind of resumes, they will just throw it in the dustbin. So because they cannot make any decision based on that. So there is a need to produce informative resumes before you can actually secure internships. But maybe I don't know, Jia Rui, want to add on to that?
All right, I'll add on a bit. Okay, so for me myself, actually I did a summer internship and semester internship, but the summer one is I self-sourced, so it's not under NTU or SPMS. So regarding this question, is it difficult for us to secure an internship? Actually, I would say it's not if you make full use of the resources available. Okay, so firstly, I would like to say that firstly, you must know what you want. Okay, find your interest, maybe through the courses that you take in NTU, firstly. Then after that, really go and see what is available in the market. The market is a very harsh place. Doesn't mean that you have this, they will hire you. You can have everything, but it might still not hire you, So what you can do is think about your future early. Have a goal, at least have a goal, go down to career fair, talk to the people. Definitely when the HR recruiter, they saw you, right, they talk to you, they were like, oh, you're from physics, you can become a teacher. Then you're like, no. Yeah, so a lot of my friends actually, they doesn't really do teaching, They do like data scientists. A lot of my friends go into data science. Yeah, they are actually quite they are quite competitive. They can even replace people from computer science and everything. Cause we have actually from our course we actually got like programming, and during our normal tutorials, other courses we also have programming, all those, and they sell themselves. They really talk to the HR, let them know what they are capable of, and give them a resume and secure the internship. Yeah, just start early because of resources, and I think it'll be fine because I secure it. Yeah.
Thank you, Tiare. Next question we have. Which programming language is most relevant for physics undergrad? Will I be taught in our modules?
So there are, because our president is of NTU is a computer scientist, so programming is a very important consideration in our curriculum. So actually, undergraduates will start by learning Python, and then we have a second course that all SPMS students have to take, and there's Introduction to Artificial Intelligence and Data Science. So that course will be in R. So effectively, students should become proficient in these two languages if they continue to take high-level courses. So I think this, again, this is something that the students need not worry seriously about. When they come, they will learn, and then they will be able to apply it in solving problems.
Okay, thank you, Prof. Moving on to the last question we have. What are the opportunities for students to develop their interest in physics apart from taking relevant modules in this field?
Okay, so I guess it's me again. So if the students are talking about how to deepen their interest in physics apart from courses, then obviously one of the most important selling point of NTU physics would be undergraduate research. But we have, beyond that, we also have our undergraduates take part in international physics competitions. It's a very selective team of students. So if they are interested, they can find out about it when they join, and then they will undergo training. So one of our former team members are training the rest of the physics students how to do this kind of competition. Then, of course, beyond that, if say the student is not interested in competition, not interested in research, just want to learn more about physics in general, they are also welcome to set up their own physics interest group. So before NTU Physics launched the General Relativity course, we actually had a General Relativity interest group, and then Ming Li was guiding them. And then there was a small number of students who attend weekly meetings to learn more about general relativity. So all these kind of things are possible because university is a very free place. So I guess you should only be limited by your imagination of what kind of things you can do.
Thank you, Prof. That is all the time we have for the sharing by the Division of Physics and Applied Physics in SPMS. If you still have any further inquiries, feel free to send us a message through our Telegram chat where our faculty staff and SPMS ambassadors will answer them. You can also check out our SPMS tours available for limited sign-ups on our open house website too. You can also drop us a text at our Telegram chat at NTU_physics. The SPMS microsite chat will remain open until 5 p.m. today, but our PAP Telegram channel will remain open throughout. With that, thank you for your time, and we hope to see you soon. Bye-bye.